this video, we're solving inequalities with 3 parts. So you may see one written like this, where we see the 2 inequalities together in one sentence here. And what this really means is, this is what another example of and or conjunction. It's this inequality here on the left and this one on the right has to also be true. And there's one of 2 ways to solve it. So the first way is, if you only have variables in the middle section, so you see this inequality here, see the inequality here, we only have variables in the middle, then it's just whatever you do to solve to get x alone, you have to do all 3 parts. Right? So if I wanted to get x alone, and so since there's only an x in the middle, I want to get rid of this 4. I would subtract 4 from the middle. Whatever I do in the middle, I also have to do on the outsides of those inequalities. So on the other side of this inequality and on the other side of that one. So this is one way that you could solve this inequality. Oops, I lost that 4. I'm left with a negative x in the middle. And 9 minus 4 is 5. And then lastly, I still want to get rid of this negative, so I have to divide by negative 1 to get x alone. But again, whatever I do in the middle section, I have to do on the outsides as well. So I end up with 1 divided by negative 1 is negative 1. I divided by negative, so I need to flip the direction, just like we would before. I have positive x in the middle, I divide by negative, I flip the direction, and then of course 5 divided by negative 1 is negative 5. So this is what we call a closed interval, meaning that it is between 2 values. So if I wanted to graph this on a number line, I have to remember that the further left I go are the smaller numbers, and then up right are the bigger numbers. And on this side, I am including 5, is that equal to bar, and I'm not including 1, and it's all the values in between. So versus different intervals, like here where it goes to negative infinity forever. This is not closed because it's going on and on and on forever. But over here, this is closed because it's between 2 values. And every time that you have closing on each side, it doesn't go on and on forever to infinity or negative infinity, then that's a closed interval. So here we have a closed answer. So that was one way you can solve that problem. The other way is to break it up into the conjunctive statements, meaning, let me get a different color here. You could say 5 is less than 4 minus x. So taking everything up to this inequality, that's 1. And going the other way, so ignoring this now, I want 9 is greater than or equal to, I need the entire middle section again. So 4 minus x less than or equal to 9. So this has to be true, and that has to be true. But we should end up with these same values of negative 5 and 1 when we solve them. So those are the 2 ways that you are welcome to solve them. So go ahead and look at the 2 on the right and try them. This one is already solved in the sense that x is alone, and you just have to think about what does the graph look like, what does the interval notation look like. Alright, let's see how you did. So this one, x is already alone. So again, there's 2 ways to think about it. One is it's on this closed interval between those 2 values, meaning I've got negative 3 and 2 here. So this says, reading from the variable, x is greater than negative 3. So that'd be everything going up. And again, we could break it into the two statements here. This isn't x is less than 3. Even though this looks like a less than symbol, you have to read from the variable. And the open mouth side is by the x, so x is greater than negative 3. Or you could flip it around, x is greater than negative 3. And over here, x is less than or equal to 2. So if I wanted to graph greater than 3, I'd use a parenthesis or an open dot, going up forever. Less than or equal to 2, I would use a bracket. I'd go down less forever. And because it's an AND statement, our final answer is going to be the overlap between those two. Where do they both occur? So they both shade between negative 3 and 2. This one had a parenthesis, so I cannot include it. It's not there in both. And this one has a bracket, so it's including on both of them. And there I would go. Again, I don't have to actually rewrite this if I just look at this. It's between negative 3 and 2. So between negative 3 and 2, all of those values in between. And in interval notation, we do parenthesis 3, negative 3, comma, 2, bracket. This next one you actually have to solve. So I want to get x alone. I'm going to first get rid of this 1. Subtracting 1 from every side. Or again, you could break it into the two statements if you feel more comfortable with that. And the same middle part needs to be less than or equal to 3. So again, you could solve them individually, and then graph them, and then find the overlap. Since I only have a variable in the middle, I'm going to continue with this, where whatever I do in the middle, I also do on the outsides. So negative 1 would be negative 2. I still have my x divided by 2 in the middle. And 3 minus 1 is positive 2. Now again, I want to get x alone, so I have to undo what's being done. This is x divided by 2. I need to multiply by 2. Whatever I do in the middle, I also have to do on the outsides. So now I've got 2 times negative 2 is negative 4. This is divided out. And 2 times 2 is 4. So that means it's going to be between negative 4 and 4. And because I have these equal to bars, I'm going to include both of them. Same thing in the interval notation. So I like this way because I don't have to solve 2 separately and end up doing the same steps where I subtract 1 and subtract 1, multiply by 2 and multiply by 2. I'm just doing it all at once. Some people are visual and they'd rather them be separated, and that's fine. But this way only works if there's only variables in the middle. These next 2 examples, I have x's over here, and x's over here, and here, and there, and there, and they're everywhere. And you can't solve it that way. So even though this is my preferred method, if I can do it, I can't always do it. Sometimes I have to break it up into my AND statement. So this is the left-hand side. Everything from the end up to that second inequality. So 2x plus 4 less than or equal to x plus 9. So this has to be true. And now I go the other way from that inequality to the end with my other inequality. So x plus 9 less than or equal to 3x plus 5. So again, that middle, I have to take everything in the middle and the left. Everything in the middle and the right. And now I need to solve them individually. So over here I'm going to subtract x from both sides. So if I move x over to the left, I can move my constant over to the right. I'm just going to go ahead and do those in one step. 2x minus x is just x. 4 minus 4 is 0. Less than or equal to x minus x is 0. And 9 minus 4 is 5. Now over here, same thing. I'm going to get x alone. I'm actually going to move my x to the left because it makes it easier for me to read it as a less than or greater than. I don't accidentally mix it up. You can always go to the right, just be careful. And then if I move my x to the left, I'm going to move my variable over, or my constant over here to the right. X minus 3x is negative 2x. 9 minus 9 is 0. 3x minus 3x is 0. And 5 minus 9 is negative 4. Lastly, I need to get x alone, so I divide by negative 2. Since I divided by negative, I must flip the direction of my inequality. Negative divided by negative is going to end up positive. Now I'm going to go graph them. So I have 2, 3, 4, 5. And they are both positive. So now, x is less than or equal to 5. I would use a bracket or a closed dot. Everything left, I shade left. Greater than or equal to, I would use a bracket. And greater than, I shade up forever. It was an and statement, so I look for the overlap between the two. So everything between 2 and 5. So sometimes you'll see that your homework or something will say, find the numbers a and b such that you end on the closed interval a, b. So in this case, a would be 2 and b would be 5. Right? So an interval notation would be 2 up to 5, including both, because everything got included here with that equal to bar and equal to bar. Alright, try the one on the right. Alright, I see x is here, and there. I can't just start solving it all together. I have to break it up into a conjunctive statement using and. So my first statement will be the left-hand side and the middle. 2x plus 2 less than or equal to x plus 4. And, so that has to be true, and right here I'm starting from the middle, x plus 4 less than or equal to that whole left side, 3x plus 7. And now I need to solve them individually. So I want to get x alone. I subtract x from both sides. And I have x plus 2 less than or equal to 4. And I subtract 2. So x is less than or equal to 2. I do the same thing over here. Again, I like moving my x's to the left so I can read it from left to right. It wouldn't be wrong if you did it the other way. You just have to keep track of your inequality. So if I move my x to the left, I'm going to also move my constant to the right. Let's go ahead and do it all in one step. X minus 3x is negative 2x. 4 minus 4 is 0. 3 minus 3x is 0. And 7 minus 4 is a positive 3. I divide by negative 2 to get it alone. And since I divided by a negative, I have to flip the direction of my inequality, and I end up with negative 3 halves over here. Alright, so from there, I've got my two key points here. I'm going to graph it. And negative is smaller than a positive, so it goes on the left. That's 1.5. So 1, 0, 1, 2, technically it's between those two. And so x is less than or equal to 2. So equal to, I'm going to use the bracket. Less than, I'm going to shade left. Greater than or equal to, we're going to use a bracket. And greater than, I would shade up. Because it's an and statement, I look for the overlap, and that's between that 3/2, negative 3/2, and positive 2. And they both had brackets, so I can include everything, including the ends. And in interval notation, that would be negative 3/2. Oh, it's freezing. Sorry, my marker was freezing there. 3/2 up to 2, including all of it. And there you go.